Okay, all right. So if you have some form of a textbook today, that'd be great. It doesn't matter if it's an online version. Now, here's my question to you: did everyone receive an email from me this weekend with your online password and login information? Hopefully it works for you and you can log in. I gave you the link there. You can always find it on my website, but it was just something like, I just thought it was easier just me emailing it one at a time so that we're not searching in class and you're trying to guess at it. So hopefully that works for you. If you like it, use it. If you don't like, because I know some people like the physical copy, I totally understand. Some people just want to touch the book. Notes day, draft paper. Did everyone receive draft paper yesterday? Fox, I think you were gone yesterday, so you'll probably need it. Does anyone else need the draft paper from yesterday? Okay, you will want that out today because we're going to do a couple examples. It's just for notes, just keep that in mind. Today, you will not be required to graph anything, but it's nice if you want to draw a picture of it and kind of see what it looks like. So, alright, so everyone's got draft paper. Okay, I got 4 examples I'd like to go through, then I'm going to turn you loose on homework and you'll have plenty of time to work. Okay? Alright, first example I'd like to cover today. I want to talk about midpoint. This is going to be kind of a review of what we talked about yesterday. What is a midpoint again? What is a midpoint? Center of what? Of a segment. Okay, so we get the idea, right? We're going to do a midpoint now for a number line. So I'm going to review the actual formula with you. You will want to write the formula down. I have it on the board next to you over here. In case you didn't get it written down correctly when we're going through it now, you want to write it down. I'm going to put it up here just so you can see it and it's on camera. So here's the formula we're going to use to find midpoint. You're going to add 2 numbers together. Now I number them x1 and x2. You're going to add both x's together and then divide that by 2. Because what you're doing is you're finding the average of them. Like literally the number in between them. Now again, I'm saying that we're doing this for a number line. So what I'd like you to do, in your notes, let's draw a number line and let's go from -5 up to 3, positive 3. So, let's draw this number line. So, -5, -4, -3, -2, -1, 0, 1, 2, 3. So, -5 up to positive 3. And let's start at -5. Let's start that's letter M. I'll give you some new letters for that. M, N, O, P, Q, R, S, T, and U. New letters here. Okay. I know some of you are still drawing. What we're going to try to do is find the midpoint of 2 dots. So let's say my dots on this particular problem are at, let's go from -5, that's my M, and let's go up to T, 2. So -5 to 2. So it's M to T. So I want to find the midpoint of MT. If that makes any sense. Now, some people are really good visually. Like you can look up here and go, okay, my middle is going to be in this ballpark. Like they can just like pinpoint it, it's like there. But if you don't like doing the whole thing where you just count with your fingers, like go in 1, and 2, and 3, and just kind of guess. We have a formula, this one, that can automatically figure out what that number is. Even if it doesn't land on a nice letter, like it doesn't land on P or Q, somewhere in that ballpark, right? If it doesn't land on those, this formula will tell you the number you're hitting, like the perfect digit. So you don't really have to even think about it. So, x1 and x2, these are my endpoints. What are my endpoint numbers over there? Endpoints of M and T?
-5.
Good. These are my 2 numbers I'm using. -5, I'm going to add 2 to it. And then what we're going to do is once you add those 2 numbers together, those endpoints, you divide that answer by 2. This will give you that midpoint, that number you're going to hit directly in the center of it. Right? So what's -5 plus 2? -3. If you divide that by 2, what do you get?
1.5.
-1.5. So we're not landing on a perfect number. We're landing in a weird half spot. That can happen. We're landing right here. -1.5. And that's my middle. Does that make sense, like visually where that hit? Does everyone understand the formula that you're using? It's an average. You add the two, divide by 2. Okay, you're gonna have quite a few of those. Just make sure you're reading the instructions. Is it asking for midpoint, and is it giving you a number line? Questions, comments, concerns about that one? Formula's on the board there and here. Does anyone still need it? Because I'm about to erase it. No qualms on my erase. We're good? All right, let's jump in. Let's do now distance on a number line. All right, let's get rid of that. Let's get rid of that. Okay. Okay, let's talk about how to find distance on a number line. Distance is one of the simple formulas that we talked about the other day. What you do is you take your two x's, your two endpoints, you subtract them this time, and you put them in absolute value bars. The absolute value bars will make your answer positive. I want to know the raw distance from one to the other. That's what I want to know. I don't care that it's negative or anything like that. I want to know how many bunny leaps. You could count the spaces by hand, the gaps between them, not the hash marks, but the gaps. You can do that, or just plug the numbers in the formula and you get the exact spacing, right? So, let's talk about how that works. What are my n numbers? -5 and 2, right? So I'm going to subtract it. It does not matter the order that you put them. You take the two numbers and you subtract them. So it could be written like that, or maybe you're the person who wrote 2 first and you're going to subtract the -5. Whatever the endpoints are, you subtract them. So -5 minus 2 more, what is that, -7? And what's that absolute value of -7? 7. There's your distance. In fact, if I just count that with my fingers, 1, 2, 3, 4, 5, 6, 7. Yeah, there's 7 gaps between it. It's literally 7 spaces. This one right here would be the same answer. These would add together because the two negative signs would cancel. 2 plus 5 is 7. The absolute value is 7. It's still 7. Because the absolute value is always positive. Questions at all about distance? Do we feel comfortable with the two formulas? You can do it, on calculator. I don't mind. I put the calculator so you don't get it wrong. But just keep in mind, I want to see kind of what you're doing. If you're counting with fingers, that's pretty straightforward. I mean, some of them are kind of easy. All right. Questions before I even move on? I'll do any more examples if you need. Like, if you want me to go back to midpoint or do this one again, I can do any example you want, so we have plenty of time. We're good with those two? Good. Let's go to the next one. All right, so next one, you're going to want your graph paper. So take out the graph paper. Hopefully everyone's got graph paper. If you don't, let me know. Some people did lose it in the last class. I can lose it in one day, but it does happen. Some people are not as organized as others. Okay. What we're going to do first is we're going to find midpoint on a graph. Okay, a coordinate plane. This has its own formula to find midpoint. That's the dot directly in the center. So again, this is for coordinate plane, Cartesian coordinate system. Okay, now the formula. Did I write down the formula for you guys yesterday? Did we get it? Formula? Okay, all right, here it is. Here's the formula you want to have written down somewhere. It's just like the midpoint formula for the number line. It has two coordinates. So you're going to add the two x's together, divide by 2. That'll be one of your numbers. And then you're going to add the y numbers together and divide those by 2. That's how you find midpoint. It is literally a dot, a point, that's in between them. That's what this is representing. It's representing the physical dot on the graph that would hit the middle. Does that make sense why it's two numbers and they're separated by a comma? Okay, let's draw something. So if you have your graph paper, I would assume that we're on probably, the second graph if you actually drew one yesterday. I would assume we're on the second graph. If you just starting, this would be your first. Let's put dot A, point A, let's put this at, let's go -3, 4. Let's go -3, 4. And let's go dot, for point B, let's put this at 7, -2. Okay, so I'll give you a little bit of time. Go draw both of those dots in the same graph. Once you have them drawn, draw the line that physically connects them. Now, before you commit and you're doing it with pen and whatnot, just double check that you're drawing it in the right spot. This is kind of that practice right now. Do you know how to graph that? -3, 4, 7, -2. Okay, so here's my question to you if you were here yesterday. What was the hint that I said how to draw these?
Pick your elevator and go to the floor.
There you go. You pick the elevator, then you go to the floor. This is the lobby of the hotel you're in. You have to pick your elevator. Your elevator is 0 elevators right in front of you. You have 1, 2, 3, 4. And you have -1, -2, -3, -4, right? So you have to pick the elevator first, then you go to the floor that you want to go to. So then you go, first floor, second floor, third floor. If you go negative, you're going to the basement. So on letter A, what quadrant should I land in?
The second quadrant.
Second. Yeah, second quadrant. Over here. This is first, that's second, this is third, and this is fourth. So you're getting used to that idea again, right? They're Roman numerals. They're ending. They go counterclockwise. Letter A, point A, is ending up at -3, 4. That's -3 over. That's -3rd elevator, 4th floor. Here's letter A. Next one. Where is B landing? What quadrant?
Quadrant 4.
Quadrant 4, right? Because you're going 7th elevator over, 5, 6, 7, and -2nd floor. So here's letter B. There's my line segment. Does that make sense, like how I drew it? Picked my elevator, went down to the certain floor, or up to the certain floor. Now, visually, to me, this looks like the middle. Do you agree with that? That's roughly looks like the middle to me. I'm guessing. That's why having graph paper is nice. I can visualize where the midpoint's going to be. Now, I don't know if that's going to be a nice clean number, if that's going to be a decimal. This formula will tell me where the middle is. Some people can kind of see it. I can visualize where it's at, but I don't know the exact number. So plugging these in, when you look at your two coordinates, these are ordered paired coordinates. They're literally in alphabetical order. So x's are first, y's are second. That's how it always works. So my x numbers, what are my two x numbers there? -3 and 7. Those numbers go here. So -3 plus the 7. Then you divide by 2. Those are my two x numbers. My y numbers, 4 and the -2. Literally alphabetical order. That's how I can see by looking at those coordinates. X's are the front numbers, y's are the second numbers. Okay, what's -3 plus 7? 4. Divide that by 2. 4 plus a -2. 2 divided by 2. So the coordinate I'm going to land at, that's the perfect middle. 4 divided by 2 is 2. And 2 divided by 2 is 1. This is the coordinate where the midpoint is. So, to prove that point, going over 2, up 1. I nailed it. Visually, I can tell where the middle is. But just proving that dot takes the formula, because it might be in the middle. You could be in the middle where it's I've had one before where, the middle was 2.5, 2.5, 6.5. I've definitely had a graph that's done that. Question?
So did you simplify the fractions down to get to 1?
Yeah, so whatever these fractions are, just divide them. I don't even care if it's decimal, top divided by bottom. I'm totally fine with that. Yep, always try to simplify them. Just divide them on a calculator, that's the easiest way I can tell you. But yeah, if you're getting a weird decimal, trust it. It could happen. 2.5 over, 2.5 over, 6.5 up. You're like in the middle of 2 dots. It can happen. So don't feel like you're always going to land on a crosshair every single time. All right, questions on midpoint, what that means. It's literally a dot, a coordinate where you're landing. Okay, and I believe the formula's up here. Yeah, it is, right there. I'll leave those up there so you can see it. Okay, we're good so far? Okay, last one, we're going to talk about distance now. This is something that I don't think we even brought up yesterday. I think I said I was going to. So let's do distance on a coordinate plane. So I'm going to just stick with the same example. It's the easiest one I can talk about. All right. Same 2 coordinates. Now what we're going to try to find here is the raw distance from one dot to another dot. Now I'm going to show you the formula. The formula is really goofy, but I will explain today like where it comes from. Because once you see where it comes from, you cannot unsee it. Like you'll know it for sure. You probably recognize it just when you see it here. You probably won't. So we're going to find distance. So that means the physical length from one dot to another. I want to know how long this stick actually is. That's what I want to know. It will not be a clean number. These will be nasty decimals. You will need a calculator guaranteed. So if you need to go grab one, go grab one. There's some in the back. If you have a calculator, take it out. They're below the basket over there. So Dave, if you want to bring out that little white tub, there should be 10 calculators in there, right? Is there 10 in there? Yeah. Go grab one. If you have a calculator, take yours out. I'll show you how to use it better. It should take us about less than 5 minutes to do this. Yeah. Okay, we're good? Everyone's got it? Okay, here's the formula you're going to want to write down. It's really goofy. Trust me, go with it. Okay, so distance equals a big square root. I'll explain that here in a minute. It's a big square root. Now, on the inside, you're going to subtract the 2 x's. In parentheses, subtract the 2 x's, whatever the 2 x numbers are. And then you're going to square that answer. Squaring means to take it times itself. Then you're going to add the difference in the y numbers. So you're going to subtract the 2 y numbers and square those. It's a goofy formula. Like, once you see it, you're like, God, that's weird. Like, where did they come up with that? It's really kind of like out of nowhere. And it just seems like it's on a different level of difficulty compared to the other 3 we've done. But once you see it, like where it comes from, it'll make total sense here in about 5 minutes. Okay, but let's do the example. Let's plug the numbers in from the picture into the formula so we can actually type it in your calculator, because that's really all it requires, just it requires a calculator. Okay, so over there in my coordinates, what are my x numbers? -3 and 7. Okay, so we're taking the -3 and 7. -3 minus the 7. I don't care the order you put them. It does not matter the order you subtract them. You just have to subtract the 2 x's. Okay, so again, these are my x numbers. Right, those 2. My y numbers. That's the 4 and the -2. I'm going to subtract those. Whatever the 2 numbers are, you always subtract. And then this will be under a large radical. Everyone understand where I plug the numbers in? X's and Y's. Okay, let's do the math here, and then I'm going to try to show you how to type in your calculator so you know the exact digit. Okay, so -3 minus 7 more. -3 minus 7 more is? -10. We'll square that here in a minute. We'll take it times itself in a minute. Okay? 4 minus a -2, that means 4 plus 2, which is 6. And we're going to square that. Okay, so now, -10 squared. means you're taking negative 10 times negative 10, which is
Negative 100.
positive 100. Yeah. The two negative signs cancel each other out. Yeah, because when you multiply by itself, it should always turn positive. That's actually the reason why they square it. Anytime you square something, it's always positive. The negative signs will cancel out. That's the beauty of it. 6 squared. 36. Okay, now when we add those together, we're going to get what? Square root of 136? Okay, so here's how you type this in. So if you have a calculator like mine, this is the button you're looking for over here. It's a little square key. It's right next to the number 7. Now, the weird part is it's in blue. Not the one with the little X on it, but the one that's just a normal square key. So to get that button, you have to hit the little blue button, the little shift key or second key. Then go hit the little X square key so that little square symbol pops up in your calculator. Then you can type in 136 and hit enter. And it will give you a crazy decimal across the screen. Something like that. Question?
I have a different calculator.
Okay, so now, if you have a different calculator, you're looking for just a square button by itself, like yours is right above the number 7. So you just type in a square key, that's nice. Anyone else has a separate, different calculator?
Maybe this one. This one.
That one, that little square. So you just type that, type in your number. Anyone else have a different, or wants me to show them how to type theirs? It is important that we know how to type this.
So do that and 136.
Yeah, just type in 136. Yeah, it should be automatically inside, right? And when you hit enter, we're getting 11.661, correct? Did anyone not get that number? Some people won't get decimals. They'll give them weird other things. Okay, now what this is, just so you know, because a lot of people go, okay, what is this? This is the answer. This is what we're looking for. This is the raw distance from A to B. Now what 11.6 means is they literally looked at this distance and went, okay, how do we figure out this length? It's literally putting the length of a box to this. So they're telling you how many boxes it would take to go from A to B diagonally. So it's literally doing this. It's going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.6. So roughly about there to here. This distance is exactly that distance. That's what they're saying. That's what 11.6 means. It's 11.6 boxes long. Okay, questions what the number means. Okay, this is what you're gonna have to type in. Now, most people look at that and they say, okay, that's easy enough if you follow my directions, right? You put the X's, it's easy to type in, you probably could do that over and over and over. But the problem is why? Why did they do that? That's really weird. Why they came up with that formula. Here's why. Once you see this, you cannot unsee it. Okay. To find distance on a graph, what they do is they make it a perfect right triangle. So if you can see your diagonal line, they're going to make this a right triangle. A right triangle is a triangle that has a perfect L shape, like a 90-degree angle. So they're going to make that a right triangle. They're going to drop this straight down and then go straight across. And does everyone see that it is a perfect right triangle, like an L shape? Now, why they do that is because we have this formula that you've actually learned, you just don't know it, that applies to right triangles only. It's called the Pythagorean theorem. You probably learned it at some point in one of your math classes, either 7th grade, 6th grade, 8th grade. You probably don't recognize the name. Once I write down the formula, you go, oh yeah, we did learn that. Here it is. It's a squared plus b squared equals c squared. How many people have seen that at some point or heard that before? Okay, you've heard it at least. Maybe you don't understand it, but you've heard about it. It is a formula that is strictly used on right triangles. That's all it's used for. And what they do with it is that A, B, and C are numbers. A and B are the lengths of the walls that make the L shape, the perfect L. So let's do A and B. And it doesn't matter which one's A and B. So this wall here is 1, 2, 3, 4, 5, 6. That wall is 6 in length. This wall down here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 in length. That's your A and B. So this is 6 squared and 10 squared It doesn't matter which one's A and B. And the C is the wall we're trying to find. That's what that formula is used for. This is my C. And everything's squared. Again, we'll talk about where this comes up. We're coming up to this formula like later in your textbook, and I'll show you kind of where it originally came from, other than just using it for this. But 6 squared, that's 36. This is 100. C squared. You add these together. And now, what do you call this little power? What's the name of it? It's called a square, right? It's called a square. Everyone knows that, right? C squared. When you take the square to the other side, because I want to get C by itself, I want to see, so it's called an inverse operation. You take it to the other side of the equal sign, you do an opposite. The opposite of a square is a square root. That's the opposite operation. That's what you do in algebra, right? To solve for x's, you always do the opposite to the other side. If they're adding, you subtract to the other side. If they're multiplying, you divide to the other side. Well, that's the opposite of a square, is a square root. Do you see where this comes from now? So literally the same numbers. The 10 and the 6 are literally the difference in the y numbers. These are the difference in the y, the height. These are the difference in x's. That's where they get the 10 from. It's literally the difference in x lengths. Once you see it, you're like, okay, that somewhat makes a little more sense now, like why they actually did it. But this is where that formula comes from. It is literally the Pythagorean theorem just on steroids. They're just showing it a different way. All right, questions at all? I expect to see on homework this, where you have the formula written down, you plugged in your x's, you plugged in your y's, you could do the math on a calculator. Just make sure when you square, the negative signs go away. And then you can type those in. Is there any questions how to type, or what the formula is, or does anyone need another example of it? Perfect. Homework's on the board. You have page 30. It's due on Friday. Due Friday.